Hi there, my name is Olivia Beyer, and I'm going to be presenting my digital forensics final project for the fall, which was incorporating YARA capability into PEV, a PE analysis library. So PEV is a library that's meant to do binary analysis specifically on Windows PE files, and it is multi-platform, so it can be run on Windows, Linux, Mac, which is a big benefit compared to some of the other C-based libraries that are out there. It's a pretty large open source project. The meat of it is in libPE, which is the actual PE analysis section. But there's also 11 different PE analysis tools that are included with PEV with the build that you can download, which include all sorts of things. A disassembler, something to analyze whether or not a binary is packed and what packer may have packed it, file header information, but there's also this thing called PE scan. And PE scan is kind of interesting because it's effectively a catch-all for capabilities that don't fit into one of the 10 other tools, but in order to search for what the documentation just simply calls suspicious things in PE files. So regarding my project, I wanted to figure out a good way to contribute to PEV because I really believe in it as a project. I think having a very efficient C-based multi-platform library to do PE analysis is very, very helpful for forensics people, especially on the reverse engineering binary analysis side. And being able to script things and automate it can make it much, much easier, much faster, and can allow someone with more deep reverse engineering experience to provide things to a greater forensics analysis team who might have other expertise beyond binary analysis, but that might not be their specialty. So I reached out to the creator of PEV, and he responded with a list of features, one of which was to convert the PE scan rules into YARA rules. If you're not familiar with YARA, it is a set of it's a way to write scanning rules that effectively say yes or no hit according to whatever criteria you put. YARA is pretty advanced in far as it has the ability to put in strings, regular expressions, direct byte matches. It has logic and looping associated with it, as well as a couple YARA modules, one of which is actually a PE module, which made writing these rules relatively simple. So the idea was to go through PEV or PE scan specifically, and figure out which of those rules could be translated to YARA. If all of the rules could be translated to YARA, that was great. We would have just transitioned over it all together, but we didn't want to get rid of any rules if they were not able to translate over easily to YARA's format. So the decision was to actually incorporate YARA through the YARA API directly into the PE scan C code itself, so that a user can run PE scan exactly as they're used to. The results might look somewhat different, but they're semantically the same. It will have the results of the existing rules that we kept, and then the results of the YARA scan. The benefit of moving over to YARA is that YARA is a widely accepted standard rather than this PE scan specific format, so it would allow users to add their own rule sets, and I actually have a command line ability to incorporate whatever rule set the user wants. There's so many rule sets out there that do a multitude of binary analysis sort of things. There's also YARA rules for network analysis, all sorts of things that are out of the scope. But just as far as binary analysis, there's experts out there who have spent a lot of time building rules, and this way a user with a more specialized concern that may not apply to most PEV users can import their own YARA set instead. So as far as the rules, the ones that were able to translate to YARA were the ones listed here. So there's one that looks for the normal DOS stub, so this program cannot be run in DOS mode, string, and make sure that that set of bytes is present and at the expected offset. There's one that checks for a fake entry point, so an entry point into a section that has strange permissions that doesn't look like it's a legitimate entry point. There's a bunch of strange section style rules. So this is one large PE scan rule that I actually ended up breaking out into multiple smaller YARA rules. But these check for the number of sections to make sure there's an appropriate number about what's expected, that no section is really short or of zero length, and for certain flags like having read-write executability on a section. There's also a normal image base because there are expected image bases. Obviously, just because a file doesn't have a normal image base doesn't automatically make it malicious, but does at least warrant further explanation and further investigation. There was a rule to print out the entropy, which that one I distilled down just into normal and high entropy based on how the original PE scan defined normal and high entropy. And that was a problem that I ran into repeatedly, where YARA rules are really just supposed to return a go, no go type status. They aren't supposed to return values. So some of the rules you'll see I didn't translate because maintaining the value it returned was crucial. In this case, an entropy of 7.2 versus 7.3 isn't semantically that important. What's important to know is whether or not the entropy is within normal bounds or considered high in order to signify that there might be packing going on. There's also a rule for this FPU disassembly trick, which was an interesting, very specific rule I found, which is one that is a certain sequence of bytes that indicate opcodes that are a new anti-disassembly trick that's being used with Intel processors. In that case, that's what really spurred on the idea of being able to use other YARA rules, because if there's this one very specific anti-disassembly trick, it would be great to be able to include rules in the future for other anti-disassembly and maybe also anti-VM and some of the other techniques we see. Finally, there's one for CPL malware, control panel file malware, versus regular non-malicious control panel. Again, this is one that you can see so many other use cases beyond just control panel malware for other sorts of malware scanning that other YARA rules in the future could be used for. As I said, YARA doesn't return values well, so there were two rules that I determined had to stay as is in the original C code and couldn't be brought into YARA. In those cases, it was printing the TLS callbacks, because again, in that one, the semantics is important to get the list of TLS callbacks. Knowing whether or not there are any is important, but not nearly as important as the values themselves, as well as printing the timestamp of the file. So this is an example of the original PE scan rule for that CPL malware one I mentioned. So as you can see here, it's a simple set of rules that looks at the flags for the file, the timestamp for the file, as well as one of the offsets in the DOS header. And what I was able to do was translate it into YARA, which looks very similar if you notice. There's still the timestamp check, there's still the flag check, and there's still the check on the offset to make sure it's that B8 byte. But effectively, it's a little shorter, and more importantly, it adheres to a much broader standard. So let's take a look into what I actually was able to do. I did my development in Linux primarily because I prefer development in Linux. However, this easily could have been done in a multitude of platforms, and I double-checked that this code built on all the different platforms to make sure that I wasn't writing anything that was uncompatible. So first, I'll just give you a quick look into the modifications I made. If you go into the PEV directory, and this is PEV that you can clone off of GitHub or download off of their website, in the source directory, there is an actual PE scan file, so we'll take a quick look at that. And I'll expand this out for you. So if you look at PEV, most of what I kept, or most of what's in here are the two rules that I kept. So there's the timestamp rule, which is still there, some of utility rules, as well as at the top, this is the rule here to deal with the TLS callbacks. So most of this was preserved from the original. At the top there is just the option parsing, command line parsing, things along those lines. However, at the bottom is where I can show where I changed. So I incorporated YARA here, so that after it does the TLS and the timestamp checking that is left over from the original PE scan, I moved into calling YARA. So we're creating a YARA compiler, we're compiling the rules, and we're then scanning using the rules down here. The benefit of doing it this way, where I compile and scan on the fly, is that if a user puts in a different YARA rule set than the one I have on the command line, it can automatically get compiled and scanned. As far as the other major contribution I made is this PE scan rule set. So this is the YARA rule set that I incorporated. And as you can see here, it has each YARA rule. I kept the names semantically pretty similar to what was already in there. And when needed, I kept comments to show what the magic values are. So for instance, if you scroll down a bit, you can see the CPL one that I was just showing on the screen. So now exiting out of that, I will actually demo for you one of the rules, specifically that CPL rule. So first, I will just show that it can cleanly build on both sides. So on the left-hand side here, we have the version that I did, the PEV, what I'm calling new PEV. And on the right-hand side over here, we have the original version of PEV. So I'll make both of them. And while those are building, you can see it's just the normal make file. I kept all of this the same. So this way, as I said, it was very important to me that a user who's used to using PE scan didn't have to adopt a new set of behaviors in order to use the new version. So on both sides it's built. And then we'll clear it out just to make it a little easier to see. And now what we will do on both sides is run the actual PE scan. So over here, we're going to run PE scan on this malware CPL test file. I wrote a litany of test files that all adhere to each of the rules that I was trying to test out. And I made sure to manually go in and change the files by hand rather than script it using PEV, because I didn't want to use PEV to test a PEV functionality. Rather, I used PE Explorer and some other tools, a hex editor, to go in, change values when needed. Whenever I could, I actually used the PE Explorer GUI because that kind of added a level of distance where I was changing the flag values rather than changing the bytes themselves to make sure that any offsets I used in my YARA rules were in fact correct. So let's run it with the original malware, CPL. So that's the result you get. This is what someone would have seen using original PEV. Now I'll give it a quick run on this side using the new version. So this version, it runs the same way with the exception of there is a separate YARA flag that's now part of the help and part of the option parsing. If you want, you can leave out the YARA flag, providing that the default YARA rule set that I have in the source directory is located within whatever directory from which you're running PEV, because that is a relative path. So now we can do a side-by-side comparison. So we'll look over here. File entropy is considered 5.9696, whatever. That's considered normal. If you look over here, the normal entropy rule has flagged. For CPL analysis, it considers it malware. This is according, as I said, to all those criteria that you see on the PowerPoint. Well, the CPL malware YARA rule has flagged. FPU anti-disassembly, this is a coincidence that this file happens to also have that series of opcodes. That flags as a yes. The FPU trick YARA rule is over here. Image base is considered suspicious, if you look on this side. And if you translate over here, the suspicious image base YARA rule is flagged. The entry point is considered normal. Well, if you look over here, we have the normal entry point YARA rule. The DOS stub is, let's unflag that. The DOS stub is also considered normal. And here's your normal DOS stub flag. Finally, TLS directory not found. TLS directory up here is preserved, as is the timestamp being normal on both sides, over on here, as well as over here. The last thing is the section count. There are 6 sections, which falls as neither too low or too many, so nothing comes up there. But this section down here does have what's considered a small length. And if you notice, the small length flag has also hit on the YARA rule set. So I made sure to maintain the functionality. It definitely looks a little different because it adheres to the way that YARA rules tend to flag if you were to run the YARA program itself. I also made sure not to do any special processing based on each YARA rule, because if you were to swap out with a different YARA set, I didn't want to have anything that was specific to my rule set. So the callback function, all it does is print out the name of the rule that hit, because all YARA rules should have an identifier. That is what I have for you as far as a demo goes. I will quickly switch back to the presentation now. So as far as what else can be done with this project, as I said, I think adding additional YARA rules is the real benefit of making this shift for PEV. Additionally, in some of the YARA rules, I use the YARA RPE Module, which is a utility that allows you to look up offsets and things like that in PE files for YARA. I think it would be valuable to translate PEV into a YARA module. That way every part of PEV was using PEV functionality and PEV logic. However, that was out of the scope of this project. Here's what I've provided as my deliverables. There's the source code, including the 2 files that I just showed, PE scan and the PE scan rule set. There's a README that explains a lot of what I went over in this presentation, as well as each rule in a little more depth. There's a test case report showing just what I did for the CPL malware with the side-by-side comparison for every test case, as well as the binaries I used for the test cases themselves. Then there's the hashes, just to make sure that everything transfers correctly, and this presentation itself. As far as what I used in this process, obviously the YARA library was necessary. I also used VirtualBox with Linux and Windows VMs. Windows was necessary to run PE Explorer and some of those other files. I also used files that existed already on the Windows VM to modify to get my stock PE images. PE Explorer, obviously, to run on the Windows VM. The Resource Tuner console, which is similar to PE Explorer, it's by the same developers, also to help me change some of the values in the PEs as needed, and iHex, a hex editor. Here's a list of the references that I utilized. Many of these were just to understand the intricacies of the PE header in order to know what the offsets were, how a cough file header, for instance, looks, because that's something I was very unfamiliar with, but was necessary for the CPL malware rule, and other things like that. With that, I really thank you. If you have any questions, feel free to get in touch. Again, my name is Olivia Beyer, and I hope you have